And you loved it when you did it before? Long division. I don't know why people make long division harder than it has to be. You just have to be, like, take your time with it, okay? All long division is regular division. It's the division you've learned since you were in grade school, right? 11 divided by 4. How do we do that? 11 goes in here, 4 goes out here. 4 times what gives you this? I don't know. 2. 4 times 2 is 8, and then you subtract in, right? I mean, this is what division is. We're doing the exact same thing, except we are doing the x cubed plus x in here, and we're dividing by x minus 1, right? That's what we're doing. The problem is that when we start doing this, we start getting a lot of weird stuff we have to keep track of. So the standard is not to write this down. What we do instead is we make sure that whatever's in the division box, we put zeros in places where we don't have certain x terms. Right? Like we don't have an x squared term here. We don't have an x squared. We don't have an x squared, right? So I put 0x squared there. I also don't have a constant at the end, so I'm going to put 0 at the end. So that's my numerator. And then my divisor, the thing on the bottom, is out here. And then can someone tell me how we play this game? What's my next step?
You gotta put x squared on the top.
Why do I put x squared on the top? What am I trying to do? You're trying to turn this x, just that x, that's all you're looking at, you're trying to turn it into x cubed. What do you multiply x by to get x cubed? X squared. So you put an x squared up here. It's kind of like that's what you were doing here. What do I multiply 4 by to get 11? Well, nothing, right? You use a 2 because it kind of gets you there, right, without going over. I know that I need to turn this into all this, but let me start by just at least trying to make this x and x cubed, all right? So I put x squared here. Now some teachers are real particular, like, oh, if you're going to put an x squared up here, line it up with the x squareds. It really doesn't matter, but I'll put the x squared there. That's it, right? Now, just like we did over here, you do 2 times 4, and it gives you the 8, right? So I'm going to do x squared times what? The whole thing, right? You're really doing x squared times x minus 1. So you have to distribute. So the x squared hits both of these. X squared times x. X cubed, I put it right here. X squared times negative 1. Negative x squared. And do you see why it's important that I had that x squared here? I'm going to line it up right here. It's going to be minus x squared. Any questions? Yes?
I was going to just say that, don't you have to also put the subtraction sign in?
Yeah, that would be the next, well, that would be my next step, right? When we do this over here, we do 2 times 4, we get 8, right? And then you say, oh, subtract, right? So then you change this 8 to a negative 8. That's what I'm doing here. I multiply this times this, and now I'm going to say to myself, wait a minute, I need to subtract this, right? So subtraction is the same as changing the signs, right? Everything that was a positive becomes minus, everything that was minus becomes plus. And now you just add down. The x cubes are gone, aren't they? What do I have there? X squared. Here, plus x. Here, nothing, right? So now I'm here. I'm not done, right? I'm going to play the same game. I'm going to say, what can I multiply x by this time to get x squared? X, right? Multiply x times x, you get x squared. So now I'm going to put plus x. And then I do the same thing. I take that x and I multiply that x here. So I'm doing this times that. So I'm doing x times x minus 1. That gives me x squared minus x, right? That's what goes under here. So here to here is x squared. Here to here is minus x. But I need to flip the signs, right? So I need to come in here and change that to a minus, change that to a plus. Okay, these go away. How many x's do I have? 2. Am I done? No, because I can turn x into 2x by multiplying by 2. So I put plus 2 here, okay? And then over here, that's really doing 2 times x minus 1 and distributing through. So I'm going to get this 2 times x. I know y'all, it's getting hard to see over here. 2x, and then don't forget 2 times negative 1 is negative 2. come through and subtract this row, right? Minus, plus. And the two x's are gone, and I have what here? 2. A 2. Now you're at a point where you cannot turn x into 2, right? So this is where you stop, and this is what we would refer to as our remainder. So what we put up here is, well, I mean, you could say this, remainder 2, but then you're in kindergarten again, right? So that's not the way we write remainders. What we do is we say plus the remainder over the divisor. Remainder over divisor. Come back over here. So what we're saying is this integral is really just x squared plus x plus 2 plus 2 over x minus 1, right? All that took was long division, and we've got it to that. Y'all have any questions? Can you handle that integral? You should, right? Term by term. You know right, plus, plus, plus. These are all separated. Now we can do them individually. Does this require any of that partial fraction stuff that I showed you yet? Not yet. This problem doesn't need it, right? I can do the antiderivative of that. That's 1/3 x cubed, 1/2 x squared. 2x. Two natural log of x minus 1. Why? Because we spent last class talking about, can we do this, 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 this? This is a constant over a linear. That was the first thing we looked at second thing we looked at last class. So we can handle all this. 1/3 x cubed plus 1/2 x squared plus 2x plus 2 natural log absolute value x minus 1 plus c. We're done. You like that one? Okay, good. Let's look at the next one. All right. Can I erase? Anyone need it? Do we need long division on this problem? No. Why not? Yeah, the degree on the top is smaller than the degree on the bottom. You only do long division if the degree on the top is greater than or equal to the degree on the bottom. Greater than or equal. Then you need long division. All right. Man, okay. I don't see anything easy, do you? Like basic U sub or anything? No? Yes. Oh, thank you. Yeah, that would have come back to haunt me. All right, so I don't have anything else to do. No trig sub. I don't see like square root of like a squared minus x squared or anything like that. Yeah, but it's a rational function, so I'm going to try partial fraction decomposition. And the way I'm going to do it is first, I'm going to have to see if I can factor the denominator. So look at the denominator. Do you all agree that the denominator has a GCF, a greatest common factor? Yeah, we can pull out a what? Just an x, right? X, and be left with 2x squared, 2x squared plus 3x minus 2 dx. Right, that's not high-level factoring there, right? This is a basic GCF. You can't do 2. Well, you could pull a 2, but we don't need to. Does this factor? This is a quadratic trinomial. Can you factor that? I hope so. You are Cal 2 students. Given a little bit more time, could you figure out what that factoring is? you can, let's try the guess and check method. I need the first term to be 2x squared, right? I need the last term to be a negative 2. But I need the middle term to be a positive 3x. So where do you want me to put 2? 2 here?
Yes.
And then what do you want? 1 here? And then minus here and plus here. Does that work? 2x squared plus 4x minus x minus 2. That works. Right? So that's just factoring. But do you see now that we have something over 3 distinct linear factors? Right? So now I'm going to come over here and I'm going to stop here. I'm pausing. I'm going to do partial fraction decomposition on x squared plus 2x minus 1 over x times 2x minus 1 times x plus 2. And you know what? I'm actually going to do it over here, because that thing gets in the way over there. So I'm taking x squared plus 2x minus 1 over x times 2x minus 1 times x plus 2. And I know that according to the procedure, this is going to turn into something plus something plus something, right? A over x, right? X by itself is a linear factor, isn't it?
Yeah.
Okay. So A over x, B over 2x minus 1, C over x plus 2. The question now is, what do you do, right, at this point? So this is where you have to clear the fractions. So you're going to multiply the left side of this equation by this denominator. So you multiply by x times 2x minus 1 times x plus 2. You do that on the left side, and you do that on the right side. X times 2x minus 1 times x plus 2. And then this goes away, right? And what you're left with over here is x squared plus 2x minus 1. And over here, we have to distribute that thing through to each of those 3 terms. So when I do this here to here, I'm going to show that right here. I'm doing a over x times 2x minus 1 times x plus 2. And do you all see that the x's cancel?
Yes.
Right? These are gone. So all that's left is the a and then those 2 factors. Plus, now when I do it from here to here, what factor cancels this time?
2x minus.
The 2x minus 1, right? So I'll be left with the b that was here. What else is next to it? X, right? And x plus 2. And then the last term, when I do that here to here, the x plus 2 cancels. So I'm left with the c. I still have the x. I still have the 2x minus 1. Now, last class, I kind of alluded how you can do this. There's a short way and a long way, right? The short way is to try and see if you can figure out what to let x be right now to make everything go away except this. Is there a value of x you could pick right now? Okay? Think of a value of x that would kill this off and this off, but not kill this off. Let me see. 0. If x is 0. Do y'all see if x is 0, this term goes away? If x is 0, this term goes away. But if x is 0 here, it doesn't kill this off. You see? So if I let x be 0, I could probably go find a, couldn't I? All right, so then I would have a. Now what if I want to figure out what b is? What could I let x be to kill this one and this one off? That one's a little harder. What's that? Negative 2 would kill these 2 off, wouldn't it? It would kill, negative 2 here would kill that off. Negative 2 here would kill that off. and leave this one. So then we could go find c, right? So let me just kind of, I'm not going to go through this, but if I let x be 0, we should be able to get a, right? If I let x be something, then we're going to be able to get b. And if x is, you said -2, then we should be able to get c. Do you all understand what I mean by this from last class?
Yeah.
If you let x be 0, that'd be 0, 0, -1 equals, all of that's gone, and then put 0 in for x here and solve for a. What would I have to let x be to find b? A half? 1/2, right? Take 2 times a half, you get 1. 1 minus 1 is 0. It's just, just set each of these factors equal to 0. Those are the 3 numbers. So that's the short way, right? That's the short way, and I'm not showing that intentionally because I want to do it the long way. Because you can't always use the short way. This problem you can, but let's see, how does the long way work? The long way works like this. You're going to expand everything out here. You're going to multiply everything out. So if I were doing this, what I would do is I'd wait on the a. I'm going to distribute this out. FOIL this right here, 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 here. So I'm going to have a, this side's still x squared plus 2x minus 1. This becomes, let's see, 2x squared, right? Then I'm going to have plus 4x minus x minus 2. You all understand? I'm just foiling that out.
Yes.
And then over here, plus, look over here on this one. I don't have to FOIL. I just have to multiply this through here and here. So that should give me bx squared plus bx times 2. So I'm going to write 2bx. And whenever you write these things out, the standard I would use is the number first, then the capital letter, then the variable x. That's the order I put in. Because you could theoretically put this, b times 2 times x, or you could put x times 2 times b. Doesn't matter because it's all multiplication. I recommend number, capital letter, variable. Okay, that's here, here. And then over here, same thing, right? I go here and here. So cx, 2cx squared. And then minus cx. By the way, these two come together to be a 3x, right in the middle? Right there. I still need to distribute this a through. I'm going to do that up here. So here's where I am. I've got x squared plus 2x minus 1 equals 2ax squared plus 3ax minus 2a. Does it seem like this is just a lot, or what? Plus bx squared plus 2bx plus 2cx squared minus cx. Y'all double checking my work here? Does that look good?
That 2a, is that missing an x?
2a. No, I think we're good. It's from here. This a went through right there.
So now
All right, so we're okay here? So now what we do, and this is kind of a weird thing if it's the first time you've ever seen something like this, what we're going to do is we're going to try and see if we can figure out what A, B, and C are that are going to make this equation true. In other words, in balance. So I'm going to be looking at collecting like terms. This, and this. Those are all like terms, right? They all have x squared. So I can write it like this. Let me just group them together first. When I mean group them, I'm just going to put them side by side. 2ax squared plus bx squared plus 2cx squared. So I just move things around. I'm also going to put my x's together. So that has an x in it, and that has an x, and then that has an x, right? Those all three have x's?
Yes.
So I'm going to put those side by side. So plus 3ax plus 2bx minus cx. Those are all my x terms. And then anything that doesn't have an x in it, I'm going to put those side by side. But I only have one thing without x, right? That's the only piece there without an x in it. So I'm going to put minus 2a. Exactly. So now what I'll do is, since all three of these terms have an x squared, I can pull an x squared out, right? These first three terms all have x squared, so we can pull an x squared out front. Yes?
Yes.
I'm not going to do it out front, though. You'll see why in a minute. I'm going to pull it out to the back. So I'm going to do, in parentheses here, I'm going to factor the x squared out to the back and put in here 2a plus b plus 2c. It's the same thing, right? If I distribute that x squared through, I get the same thing. Here, these three have x's on them, so I'm going to pull the x out, and I'm going to pull it to the right, out the back side. So I'll be left with, in parentheses, 3a plus 2b minus c. There's the x. And then over here, I have minus 2a. Any questions? Come on. Y'all following this? So the idea is that I have to keep this in balance, right? So notice that on the left side of the equation, the number that's sitting in front of x squared is a 1, right? And if it's going to be in balance with that side of the equation, that means I need this, the thing sitting in front of the x squared, to also be 1. That's my first equation. I'm about to create a system of equations. That's my first equation. My first equation is that, and normally when we write a system of equations, we put a big old brace like this. I know that 2a plus b plus 2c must be 1, right? Must be that coefficient. So that must match that. In addition to that, I know that this sitting in front of x must be a what? Must be that number in front here, a 2. That's my second equation. 3a plus 2b minus c must be a 2. And then finally, the thing that doesn't have an x must match up with the thing that doesn't have an x here, which is negative 1, right? So negative 2a must be negative 1.
You can just fill in the b with 0.
Yep, and now you can use your calculator. Now I do agree that you know what a is right now, don't you? But go ahead, you have your calculator. Let's see if you can do it. I don't remember having a fraction as an answer, but okay. If somebody gets there, let me know. Do you want me to put on the board what you type in or no?
Yes, please.
Yeah? You want to see all that? Okay. You're typing in RREF bracket bracket 2 1 2 1 close open 3 2 negative 1 2 close open negative 2 0 0 negative 1 close close parenthesis. Yep.
I got 5, 2, and 1.
5 2 and wait, what?
Excuse me.
Oh, 0.5. Okay, so you're getting an answer. All right, what did you get up here? 0.5. 0.2. Negative 0.1. Yeah?
Yeah.
Can you all convert those to fractions? 0.5 means 5/10, right? Which is a half, okay. 0.2 means 2/10, which is 1/5. And negative 0.1 means negative 1/10, right? I'm just converting them to fractions. So we know what A, B, and C are, don't we? We know what A, B, and C are. So let's go back to the original integral. X squared plus 2x minus 1 over the 2x cubed plus 3x squared minus 2x dx. We know that that now becomes integral, and it was three things, right? It was over x, and then it was, what was my next one?
It was over 2x minus 1.
B was over 2x minus 1?
Yes.
And then this one was the x plus 2? Right, and we had A, B, and C on top of those?
Correct.
And we know what our A, B, and C are. Right? Bless you. Our A was a half, our B was 1/5, and our C was negative 1/10. Do you understand what we've done here? We've taken this, we've rewritten it in its partial fraction decomposition, which now created three separate terms that I'm happy to see, right? These are all constant over linear, constant over linear, constant over linear. I know how to integrate those easily. What am I going to do with the half, the fifth, the negative 1/10? What do I do with those? Just bring them out front, right? When you do the antiderivative, just bring them for the ride. Are you ready for the answer? So this will be, the 1/2 is going to come for the ride. The antiderivative, imagine now the half's not here, it's 1 over x. That's natural log absolute value of x, right?
Yeah.
Okay, plus, here the 1/5 comes out front. Be a little careful on this one. What do you have to be careful with?
Do you have a 1/2?
You have a 2 in front of the x, which means you're going to have to scale out a half in front of that log. So times a half, and now a log, and then your 2x minus 1. Again, that goes back to last class, right? And then your last one, bring out that minus 1/10. We don't need to worry about scaling on that one because it's just x plus 2 plus c. There we go. That's the antiderivative. What do you think?
It could be worse.
Yeah. Yes.
Can we combine log theta and 1/2?
Oh, yeah. You can multiply this to be 1/10, right? Yeah, you could do that. You could go a lot further as well. Because, let me just show you. This could turn into natural log of the square root of x, right? I could bring the half up. This could turn in plus natural log. If I brought that up, this would be 2x to the 1/10. Thank you. 1/10. You don't need to do this. Okay, then you could say minus natural log of x plus 2, also to the 1/10, right? And then do you remember properties of logs? That if you have two logs separated with addition, you can put them together into a single log with multiplication. So you can put these two logs together and these two logs. You could have a single logarithmic answer here if you wanted to. Just telling you, you could, right? We're not going to. We're leaving it exactly the way we boxed it there.
Can we see what Wolfram Alpha will give us?
Yeah, let's do it. That's a good idea. Let's see what Wolfram Alpha does. Wolfram Alpha. I think I had it. Oh, there we go. Antiderivative. We have x squared plus 2x plus 2x minus 1 over 2x cubed plus 3x squared minus 2x dx. I feel like the internet's acting weird. What do you do when the internet goes out? Can't do math anymore, I guess. It's like running really, really slow. We'll let it think. We'll see if it comes back.
If they're using it for something else,
What's that?
they're using the computer for something else.
Yeah, I don't know. But I was trying to close my Yahoo and it wouldn't even close that. So it could be my computer's hung up, or it could be that the internet's hung up. What is that?
I blame school Wi-Fi, it never works anyway.
See, but I'm on the employee.
Yeah, you guys like doing
I'm on a different network than you guys. So let's see. Wolfram Alpha does not look like it wants to open. Let's see if Desmos opens. Yeah, Desmos opens. Wolfram Alpha doesn't. So what's another one?
halfway.
Oh, Symbolab? Is Symbolab now? Mathway? I never use this stuff, so. Is this what I do? Same thing?
Yeah,
Integrate.
there's a fraction option up there as well.
It's fraction option. X squared plus 2x minus 1 over. Whoa. That's kind of creepy. Freaking knew what the denominator should be. That is creepy. That means this problem's out of a book. Okay, so it gave the answer out of the book. I mean, it gave the answer we got, right? Oh, sorry, that's really small. You can't see that. Okay, I accept. You're already listening anyway. That's our answer? Okay. I'd be curious to see what Wolfram Alpha would give us, but we're going to move on. So if I were doing that problem, if it were me, I would probably have done it the short way. Okay, but I wanted you to see that the long way turns out to be a system of equations which you can solve, right? And like I said last class, sometimes the short way doesn't work. And there will be key indicators that'll let you know that it doesn't work. And we're going to do a problem here, hopefully, today, that you'll have an example of one that doesn't work, where the short way doesn't work. So let's try and crank this one out. Yuck, right? Yuck. X to the fourth minus 2x squared plus 4x plus 1 over